But coming back to your specific question, whether you build the communication capability or the remote sensing observation capability, and then your ability to connect various parts, these are all basic capabilities. And who the users are, we don't worry too much.
What is the lifespan of the spacecrafts that's already in the space? And if something goes wrong, can they able to separate from the ground level? What is the lifespan in these two questions?
See, the lifespan varies. The satellites are built with lifespan as small as a few months, which are very low Earth orbit satellites, to up to 15 years. For example, today all geostationary satellites which we build have a lifespan of 15 years. Now, coming to your second question, whether the satellites can be rectified from ground, they can be rectified provided you have visualized at the time of designing and launching. You have built redundancies and you have built capabilities where in case one system fails, you can switch over from ground command from one to the other. So this is ground corrected. In missions like Mars, we had to build that capability in the satellite itself. If one subsystem fails, even before interaction from ground can happen, satellite itself senses it and switches over to the other redundant system. That is what is autonomy, etc. So we have built progressively greater and greater autonomy, and these capabilities help us in designing future satellites for low Earth orbits also.
Just a minute, we'll plan it correctly. The thing is already 1.5 hours are over. I will allow 3 questions. Naturally, lady is important. No lady has asked a question. After 3 questions, the session will close, that's all. But as we move towards the star, you can put any number of questions you want. Yeah, okay? We'll start now. First question from the lady.
Thank you very much for a very good talk, sir. What I want to know is telling about the software, soft landing. What is the major difference between the soft landing and the normal landing? Any major?
Okay. See, for example, we had in Chandrayaan-1 a moon impact probe. Now that moon impact probe went and hit the surface of the moon at very high velocity. Now when you say soft landing, what you are telling is the object goes very close to the surface of the whichever place it is going to land, and the velocity with which it will touch the surface will be less than few meters per second or small. Otherwise, purely due to gravitational force, if it is getting pulled, it can impact at very high velocities. Soft landing is the ability of the craft to actually compensate for the gravitational force and move slowly towards the surface. Actually, finally the activity has to be hardware, because you have to reduce the velocity and then you have to hover practically. But for doing that function, you have a set of sensors using which you control the throttle or thrust.
Second question, elderly man.
Thank you. Thank you for your lecture, sir. One small doubt. There is a concern about space debris. So what is ISRO's contribution towards that debris?
Yeah. Today, for example, in terms of these debris, a set of activities which is supposed to be done after each launch, the spent stages, what happens to that, and then how it is passivated so that it doesn't explode subsequently and become sources of other more debris. Towards that, all activities are taken. And all geostationary satellites also have what is called a graveyard orbit, where they will be moved out of their operating location after their service life is over. Then beyond that, there will be still a set of satellites which we have launched, which will continue to move in space for a long period. And today, we are making use of the information about tracking debris in planning our own orbits. Many times you would have seen that we have delayed our launch by 1 minute or 2 minutes to take care of collision probability of the object that we are putting into space. And we are also establishing certain facility to monitor these objects in space and then trying to track them so that future our objects we can control better. But there is a problem which is going to be debated significantly in various forums, including United Nations and International Astronautical Federation, where what is to be done with debris, whether we can scavenge them, bring back. Of course, these are all discussions which are going on. No concrete actions are planned as of now.
Okay, young man.
Namaste, sir. Sir, I'm a teacher in school. So I'm more interested in getting educational material that can be used in the school. So NASA has a link in its website, so that's NASA per kids, and there are so many materials are available from the website. Do ISRO plan any such thing, sir? And further, I need the scale downs of all the satellites and launching vehicles. Can that be made available from the institution, sir? Thank you.
Yeah, it's a very interesting question. See, of course, for a long time, our outreach has been far too small, but we are progressively trying to increase this outreach. Very recently, you may be aware, we have released what is called SACAR, or trigger card based information system, which anybody can see on their mobile. And we also have on our website a large amount of small videos which describe various activities, including Mars mission, and also these small 1 minute video, half-minute videos which explain, just to give you an example, the cyclone, how the cyclone is able to be predicted using satellite information. So like that, we have our PNPR person, both of them here. We'll be more than happy to interact with you and then provide all the publicity material and such information. We also intend to involve both the school students and the college students in many of the activities which we are doing, so that they get first-hand experience in using the tools of space technology for understanding their surrounding environment and also a lot of things.
I think one gentleman is sitting in the front bench for a long time now. Naturally, you have heard more than what other people have heard. So therefore, a question from him will end this session, you know.
So what is the assistance you are rendering in oil and natural gas exploration? Oil and natural gas exploration.
Yeah, actually some work has been done earlier using, for example, in terms of gravity anomaly data, and also in terms of the sea surface studies using altimeter data. A certain amount of work is done by geologists to identify possible locations. But other than studying using the altimeter data and the data of gravitational forces using GHOST and other similar satellites, we do not have any of our own program, but we make use of satellite data available from other sources. Altica, of course, we carried that payload on our satellite and we launched. And this information is being currently also studied by a few of geologists for looking at possible locations.
I think I'll close this session and thank you. And you can meet him also as we are going, you know, there's no problem. Okay. That I got.